So the spread. So this is like summarizing the group by describing how spread our scores are or how spread our data set is. So example, let me just give you an example what actually the spread means. So I asked 15 adults how many teeth they have. So some say 29, some say 30, some say 31, but most likely all will be having 32 teeth, right? So here we can see there is not much variation in the data. So because majority of the people are having 32 and the variation will not be, it will be mostly because we are looking into adults, it will be from 28 to 32. So there is not that variability in the data. So all the data values are clumsy at one particular point, right? As you can see. So if I ask the same question, so I was checking IQ for 15 adults. So the score could be from 82 or 72, 62, 52. It could reach to 120 also, so it could reach to 120 also. So there is more spread in the data. It has high variability in the data set. So if there is high variability, so we should be looking into data which has high variability. The data should have high variability. So low variability, so if you are predicting something, so if you are predicting something, your column has x1, your column has x2. So this one will be having a teeth, okay, and this one will be having IQ. So the teeth will be having something like the same variability 29, 30, 29, 30, 29, 30. So this having a large variation, this will be explaining my y variable to the most of the time. Because if I have all zeros, can this particular column will be useful to y? No, because there is no such variability. There is nothing that particular column is explaining to my y variable if there is any y variable. So there, the spread of the data is also very important to predict your y variable. So this is something like, so imagine everything, we were working on everything, statistics and all these things. So how a spread, how the central tendency will be affecting your y variable, will be affecting your result. So this is what always we should be looking into. So if I talk about the spread, I really don't care what actually low variability, high variability is. So once we get into the data science part, how it affects the column affects my y variable is the most important to me being a data scientist or into a data science. So this will not, such variables will not work in prediction of y, and these variables with high variability will be helping you in predicting y. So always look, so once we get into what are the different methods we'll be looking into to understand the variability, always look for the variables or the columns which have high variability in it. So let's get into the topic, the spread. So as you know, so this is how you can see the spread of the data, low variability and high variability. So the mean score, if I talk about something, let me just get into this part. So the measure of spread, it mainly used to help the summarize how the score. So if you can see, don't look into all this stuff. I just got it from the Google source. So take the marks, only the marks file here. So the mean score of some 100 students, if you could tell me, the mean score of 100 students may be 75 out of 100. So this is the mean score out of 100. However, not all the students will be having 75 marks, right? So it is just an average. So this all the scores will be spread out around this 75. So that is called as spreading of your data, measure of your spread. So because the mean score is 75 doesn't mean that man every student will be getting 75. So every student will be around this 75. So all the records, so it could be only this is one record. So there are like another 50 records and 49 records will be around 75. The spread of the data. So like if you take like Hemant, so me, I am getting 100 marks greater than the mean. So if I tell that average score of my class is 75, so if that in that case, so being me, I got 100 or 10 marks greater than the mean because I am a above average student. I could say that one, right? At least with the data which I have in my hand. So some way, or some will have lower and some will have higher scores. So measure of spread help us to summarize how the spread out the scores are around the mean. So the spread of the data, how to know the spread of the data. So there are different things to understand the spread of the data. So we know how to calculate the mean, median, mode. So now we got the mean into action. Taking the mean, we can determine the spread of the data or particular column. So what are the different methods to check the spread of the data? So these were the four methods where you can check the spread of the data. One is range, another one is quartile or interquartile range, variance, and standard deviation. I guess this is the one which you might have heard about many times in your life, standard deviation or variance. So let's get into that part. Range. So what is the range? So can anybody tell me range? By the name itself you can tell that. So the range is the difference between so your lowest value and your highest value in the data set. This is like a simplest spread of measure. So difference between lowest and the highest value. So for example, if you take a restaurant meal study, so a city meal will be costing around 62 rupees or $62. $60 is a pretty good expensive meal. So imagine the range of a city meal is 62 rupees and a suburban meal cost is 46 rupees. So you could conclude that meal cost in cities they show much variation than suburban meals, man. We really know that. So if I tell the city meal is this much and suburban meal is much lower than the city meal, we always know that. So what is the difference between what is the range, right? So this range is not as great. So we shall not be using the range. So at least from my aspect, so many of the times I really don't use range at all. So just we are getting into the statistics. So I was explaining you what actually the range is. So most of the time, no, range will not work in any of the way, right? So the disadvantage. So if you have like extreme high or low values, so it could give a big variation, right? So the same way, if there is Bill Gates on the very right corner and if there is something very low in the left corner, so if you take the range, man, it will be like a huge range which is not right. So if you have any extreme high or low values, so your range will not work at that particular point of time. We shall be getting into the another spread of measure, which are quartiles and interquartile range. So what is this quartile? Quartile tells about the spread of the data, how spread your data is by breaking your data set into quarters. So quarters, what do you mean by quarters? Quarter is 25 percentile or 25 percentage. So I have four quarters in $1, right? So I have 25 paise, 425 paise in 1 rupee. So that we are dividing the whole data set into quarters after we arrange the data. So everything should be arranged, man. So if you don't arrange the data, it will be a wrong thing if you are looking into the spread of the data. So your whole data, so this is how it breaks your whole data. I'm just giving you a simple example here. So if you see here, there are three splits in the data. So you said there are four quarters. Yes, there are, right? One, two, three, four, right? So with the three splits, we are dividing the whole data into four quarters. So this one will be your median. The middle one will be your median. So let's get instead of directly getting into the median part. So the first quartile. So this is a value. So if you take this value, so this value tells such that 25 percentile, 25 percentile of the rank data values or the data values are smaller than the 75% of the data. So 25 percentile of the data is less than. So these values which come after the first quartile are 25% of the data set. Then what is the second quartile? So we have another name for this one, median. So as discussed, this will be splitting the whole data into equal two parts. Next comes the third quartile. So if this comes 25 percentile, so this is obviously before this one, it is 75 percentile. So 75 percentile of the data values are smaller than the third quartile, and the remaining 25 percentile of the data value. So imagine, just don't take into the percentile things. So 25% of the data is after, so your third quartile, and 75% of the data are before third quartile. So this is a very simple thing you could understand. So quartiles are especially useful to measure the spread of the data when you put in a graphical form. So if you want to understand the data, if you want to know what actually the data is, so this is how we can define first, second, and third quartiles. N plus 1 divided by 4 will be giving you the sample first quartile. The same way, n plus 1 by 2 is our median value, and 3 n plus 1 by 4 will be giving you the third quartile range. So as discussed, so these quartiles are mainly used to understand the spread of the data when we put in a graphical form. So this is useful when we put in a graphical form. So this is a kind of a box plot, box whisker plot. So we'll be getting into that one as well. So when, and the second useful thing is like when you are working with the data that isn't symmetrically distributed, so just by looking into the whisker plot you will get to know. So these are the whisker plots which we'll be knowing. So there is something which is similar to this one. So if there is so much of data in this quartile, it is skewed to left or skewed to right. We'll get into that one also. So Just by looking into the box and whisker plot, we can understand the symmetry of the distribution of a particular column or a variable. So, and also we could know, we can understand. So if the data isn't symmetrically distributed, we could also get it. And finally, if the data has outliers or not. So by looking the box and whisker plot, we can understand if there are outliers or not in the data. So, man, we are done with this one. We are done with the quartiles part. So let's get into the interquartile range. There are so many quartiles and interquartiles. I hate this stuff. So the distance between the first and the third quartile is called the interquartile range. So taking this interquartile range, so as said, so it is like from Q1 to Q3. So interquartile range will be from, so this is my interquartile range. Okay, now what to do? I have my interquartile range. So it's just the distance between the first and the third quartile. So IQR, this interquartile range will tell us how the spread out the middle values are. So if you have so much of data in between, it is a good sign that we have a normal distribution. So it can be used to tell when some of the other values are too far away from my center values. So it will tell us, my interquartile range will tell me that how the other values are away from my center values. So how to do that? So other values are away from my center values. What do you mean by that? They are like nothing like your outliers. So these were the extreme values which are called outliers. So this one is, these are the Bill Gates, right? So extreme values. So one is rich Bill Gates and another one is poor Bill Gates. I mean, so we could, with the help of the interquartile range, we could tell what actually the outliers are. So because they lie outside the range of what we need to expect them. So one thing, how to calculate with the interquartile range, what are the outliers? So first thing, if you are looking for these values, right? So Q1 minus 1.5 multiplied by IQR. So this will be giving, if you have a data, if you have a column, so just if you apply, I really don't apply because we have all the functions out of it. I really don't do all the calculations, man. All I need you guys to know is, yes, we could calculate with the interquartile range with this particular given equation. So this equation will help you to understand what are the values below the boundary. So these values come under lower boundary. So this we call it as whisker. This thing we call it as whisker. So anything which are above and below these whiskers are outliers. So how to find extreme low values, which comes under the low boundary phase? With this equation, you can find out the extreme low values and the extreme high values. So how to find out extreme high values? Any guess? So we found out extreme low values. Then how to find out the extreme high values? Anyone? So just by
1.5
Q3. Okay, Q3 minus So Mahesh, so yes, Q3 not minus, but it should be plus, obviously, right? So minus will goes into this side. So if we add any value with Q3 plus your 1.5 into IQR, will be giving you the values, extreme values, which are above the Q3 whisker. So is that the right? Yes, that is the right. So this is how we can calculate the outliers from the data set. So these were very important things. So one thing, so if I give you some homework, so let me just give you some homework. So how did I get this equation? Why 1.5? So take this as a homework. So Q3 before and after and IQR, that's okay. Why 1.5? Let's have a discussion over this one. Why 1.5? I want to know why we are using. Can I take 3.5? Can I take 10.5? I can take any number. Why only 1.5? This is a basic thumb rule for understanding the lower and upper boundaries. So tell me, so in WhatsApp, so why we need 1.5 only? Because as in a thumb rule, right? So let's get into the next part. So everything, guys, so everything I am explaining you, I am mentioning here a link for that one. So if you are so much interested, so enthusiastic about understanding much more in a greater depth for the interquartile range, so you could just go to the links which I have given